under fractions. The subheading, we usually go this one, rather than calling it what it does, which says, well, you will hear most people say to do this, write this down. Under fractions, we were talking about cross canceling, which is simply, like the book said, reducing fractions before you multiply. Ooh. I'll let you write that down, and then we'll talk just a little bit about it. Got that problem written down? 5 6 times 1/5. Well, let's actually do this problem out. And sometimes reducing cross-canceling saves you a lot of time, sometimes it's just a little. But if I multiply this out, I end up with what? 5 over 30. And then I have to reduce what number goes into both 5 and 30? 5. So I divide top and bottom by 5. And I end up with 1/6. Well, children, there's a little thing called cross-canceling, and you've actually been doing that before. If I took this and kind of rewrote it so that it looked like this, 5 times 1 over 6 times 5, do you remember doing that whole prime factorization thing where you had like 2 times 2 times 3 on top, and then you had 2 times 3 times 5 on the bottom, and you could go, oh, I can cross off this 3 with that, 3 with that, 2 with that, 2. Well, the same thing is true. That's really what this is right here. Okay, and you can save yourself a lot of time and probably stop a lot of mistakes if you do this cross-canceling thing. If you see 5 6 times 1/5, okay, you can reduce stuff before you multiply as long as it is a top with a bottom number. It doesn't matter where the bottom number is. In other words, if you see 5 over 5, what number goes into 5 and 5? 5. So you could divide both of those by 5 before you multiply. Divide that by 5, you get 1. Divide this by 5, you get 1. And then once you've done all that, everything that reduces, you can just multiply like normal and you get the 1/6 without having to do the reducing there. To which you're going to say, well, you know what, that's kind of confusing for just doing something I came up with. But if you get to bigger fractions, for example, if you get to something that looks like this, well, maybe they don't give us really big ones just yet. You know, if you ended up with something like this, I'll do 5 6 times 1/3 times 7/15, you know, times, I don't know, 8 over 21. Okay? For you to multiply all of those top numbers together, and then multiply all those bottom numbers together, and then try to reduce all that, it's going to take some work. But what cross-canceling says is that if you see top numbers and bottom numbers that have the same factors that you can reduce, you can do all the reducing before the numbers get real big and it's hard to tell, and then see what you end up with. But you can only do it once. For example, you have a 5 on top. Does 5 go into any of these bottom numbers? 15. So you do that. You divide 5. You can divide by 5. This becomes a 1. 5 goes into 15 3 times. And you see, I don't know. Oh, 7. Does 7 go into any of the bottom numbers? 21. So you cross off the 7. It goes into itself once, into 21 3 times. Now it doesn't have to be. Look at what's left here. 6 and 8. If I had the fraction 8 over 6, could I reduce that by something? What number goes into both 6 and 8? 2. So you can do that here. 2 goes into 6 3 times. 2 goes into 8 4 times. And then you look around and you see, is there anything? Four, ones, once you get to ones, there's no way you can do anything. You could look with the fours, but all you have are 1, 2, 3, 4 threes and a 4. 4 doesn't go into any threes. So once you get it all reduced, then you can do your multiplication. 1 times 1 times 1 times 1 times 4. And 3 times 3 times 3 times 3 is actually 9 times 9, which is 81. That whole thing. And if you do all the cross canceling, you'll never have to reduce much at the end, if at all. Now, had you not done the cross canceling, you would have ended up with 5 times 8 is 40 times 7. You would have ended up with 280 on the top. I don't know if I want to do this. You would have ended up with what? 18 times 15 times 21 on the bottom, which is going to be some astronomical number there, something in the thousands. So cross canceling is very much your friend, and you want to do it because it's easily going to save you a lot of time. Now, can you cross cancel when you divide? Yes or no?
Yeah.
The answer is yes and no.
Yes.
You can only cross cancel on division after you've made the division problem a multiplication problem. So for example, if you have 5, 6 divided by 5 over 2. First of all, something could cross cancel there, you couldn't do it because it's not multiplication. It must be multiplication. But what you realize is, how do we do division problems? We change them into multiplication problems. You take the second fraction, what do you do with it? You flip it and you multiply it. So this becomes 5, 6 times 2/5. And once it becomes a multiplication problem, then what cross cancels? Well, the 2 5s become 1 because they go into each other. And the 2 and the 6, 2 goes into 2 once, 2 goes into 6 3 times. You end up with 1/3. 1 times 1 is 1, and 3 times 1 is 3. So yes, you can cross cancel with division, but you can't do it until you make it a multiplication problem. What about mixed numbers? 1 1/9 times 1 1/5. 1 1/9 times 1 1/5. Can I cross cancel those? Yes and no. I can't cross cancel until you make them improper fractions. 1 times 9 is 9 plus 1. You end up with 10 ninths. 5 times 1 plus 1 is 6/5. Once you get to this point, then you can cross cancel. And what would cross cancel there? Yeah, 5 goes into 5 once, 5 goes into 10 twice. What number goes into 6 and 9? 3. 3 goes into 6 twice. 3 goes into 9 3 times. Can I cross cancel the 2's? No, because it has to be a top with a bottom. Can't cross sides, you have to cross top with bottom. So your answer is 2 times 2 is 4. 3 times 1 is 3. And I can't leave 4/3 because it's improper, but I can change it to a mixed number, which is 1 and 1/3. Cross canceling is a very, very important part to your future. How about this? Let me give you one. 8 ninths divided by 2/3. What is 8 ninths divided by 2/3? 8 ninths divided by 2/3. Eight ninths divided by 2/3. Tyler? Let's check. It's always the second one we flip, so this becomes 3 halves. 2 goes into 2, 2 goes into 8, 3 goes into 3, 3 goes into 9. You then get 4/3, and that's 1 and 1/3. Everybody's happy about that?